Imagine that you hop on a futuristic Hyperloop, and in less time than it takes to grab a coffee, you're cruising from Shanghai to Hangzhou. The best part? It's not just talk, it's real. So what makes a train not just high speed, but ultra high speed? How do they push the boundaries of speed, safety, and innovation to create a behemoth that defies the limits of conventional travel? We're about to unveil the secrets, unravel the challenges, and explore the sheer ingenuity behind constructing the world's fastest train. So China's got this incredible thing called the hyper-high-speed rail, and it's no ordinary train. We're talking about mind-blowing speeds, 1,000 kilometers per hour. To put that into perspective, regular planes fly at about 900 kilometers per hour, and even the fastest Boeing 747 hits 1,120 kilometers per hour. And get this, the Hyperloop in China is set to match that speed. This hyper-high-speed rail is a marvel, a colossal, ultra-high-speed, low-vacuum tube, maglev transportation system. Translation: it's a super-fast train gliding on a magnetic track in a vacuum tube. And this is not just any tube, it's the longest and largest of its kind in the world. But how does it work? Well, it's a blend of magnetic levitation and low-vacuum technology. Think of it as flying on land, a high-speed flying train, if you will. Now, this Hyperloop is not just a dream. It's about to hit the testing tracks. If all goes well, the future holds a breathtaking connection between Shanghai and Hangzhou in just 9 minutes. It's the stuff of the future, and it's happening right now in China. Now, I know what you might be thinking. Zooming at 1,000 kilometers per hour sounds like a recipe for danger, right? But hold on, it's not as risky as it seems. The key here is not the speed itself, but the safety measures in place. Let me break it down for you. See, the Hyperloop isn't just about raw speed, it's about being safe. The real danger comes from unsafe factors, and guess what? The Hyperloop has tackled those head-ons. Here's why it's actually safer than your regular high-speed rail, airplanes, or trains. First off, the Hyperloop rides on a fully enclosed track, shielded from the chaos outside. It's like a high-tech subway in a tube. Since it's magnetically levitated with no wheels, it's not at the mercy of other vehicles or wandering off course like an airplane. Wind. No big deal, the enclosed pipeline shields it from those gusts. Next up, the straight track. Unlike highways or traditional railroads with twists and turns, the Hyperloop zips straight through. That means fewer chances of risky turns, making the whole journey safer. And let's talk tech. The magnetic levitation system reduces mechanical failures. Unlike traditional trains with wheels grinding against rails, the Hyperloop glides on a magnetic force, minimizing friction and vibration. Back in June 2020, there was this bold idea to dig super-fast railway tunnels in the United States. But Dubai beat everyone to the punch. On February 21, 2018, the Dubai Roads and Transport Authority, or RTA, lifted the curtain on the mystery of a groundbreaking technology, the Virgin Hyperloop. It was the first time the Hyperloop design was shown off to the world, and it was a game changer. Imagine this, you could zoom between Abu Dhabi and Dubai in just 12 minutes. Currently, that same journey takes a whopping 90 minutes by road. This is not your ordinary train. It's a magnetic levitation marvel. This capsule glides through the air or tunnels under colossal low pressure. Think of it like a futuristic subway that's not bound by the rules of gravity, and it hits speeds of 1,000 kilometers per hour. That's 3 times faster than your everyday high-speed rail, and over 10 times faster than traditional railways. It's not just fast, it's a whole new level of fast. Now, you've probably heard of magnetic levitation and electromagnetic technology, but what about low vacuum technology? Low vacuum tech is all about playing with materials in a vacuum environment. It's like creating a space where things can happen without the interference of air and pressure. It's clean, it's efficient, and it's the backbone of the Hyperloop mechanics. This tech uses the flow characteristics of materials in a vacuum to process them in a low temperature, atmosphere-free, and low pollution way. It's a field involving vacuum production equipment, detection tools, and materials. The trick is to control the gas pressure on the material surface, making it bend to our will for various processes and property changes. In the realm of low vacuum tech, we've got vacuuming isolation, gas dilution, and other methods. The principle is pretty neat. Imagine using a vacuum pump to suck out all the air from a sealed chamber, reducing the pressure inside until it hits the low pressure sweet spot we're aiming for. Now, there are two ways of vacuuming: atmospheric pressure vacuuming and low pressure vacuuming. Atmospheric pressure. Vacuuming is like the grand exit of gases from a packed room, leaving it in a low pressure state. On the other hand, the low pressure vacuuming isolation is where we seal them in a cocoon, isolating them from the outside world. This isolation reduces oxygen, moisture, and other components, preventing oxidation and environmental pollution, a shield for our precious materials. Gas dilution is another process. It's like injecting protective gases, such as nitrogen or argon, into a vacuum environment to dilute the oxygen and other molecules. This protective cocoon ensures the safety and preservation of materials and components. Now, where does this low vacuum technology come into play? We're talking material processing, physical experiments, electronic device manufacturing, you name it. And here's where it gets exciting for the Hyperloop. According to a report from Hong Kong's South China Morning Post, vacuum technology is the Hyperloop's secret weapon against air resistance. When high-speed trains are on the move, air resistance is the thing trying to slow them down. But with low vacuum technology, the Hyperloop slashes air resistance by at least 3% compared to traditional high-speed rail. Couple that with magnetic levitation, and the Hyperloop is practically flying close to the ground, defying the odds and making high-speed travel smoother than ever. As of 2022, China is a powerhouse in the realm of railways, boasting an extensive operating mileage of 155,000 kilometers, with a jaw-dropping 42,000 kilometers dedicated to high-speed railways, a global record. But China is not resting on its successes when it comes to land transportation speed. Since 2017, Chinese researchers have been hard at work developing high-speed flying trains, pushing the boundaries of what we thought was possible. These flying wonders promise a future of unparalleled speed and efficiency, with the ambitious high-speed plan unfolding in 3 steps. Speeds of 1,000 kilometers, 2,000 kilometers, and a mind-blowing 4,000 kilometers. To put that into perspective, it's more than 4 times the maximum cruising speed of the Boeing 737. Imagine cruising through the vast expanse of China in just one day. Technology is turning this dream into a reality, propelling high-speed flying trains from mere concepts to tangible, fast-moving marvels. But before these high-speed flying trains can truly take off, they need to undergo rigorous testing. That's where the high-speed flying train speed test line verification project in Dongsheng, China comes into play. On November 10, 2023, with the completion of the last set of module support bosses, China marked the completion of the main project of the world's longest and largest full-scale ultra-high-speed low-vacuum pipeline maglev transportation system test line. A mouthful, but it signifies a leap forward in transportation technology. This test line, stretching across Dongxing County and Detong City, is a groundbreaking initiative. covering 2 kilometers and equipped with the world's first ultra-high-speed low-vacuum pipeline maglev transportation system. The project, unveiled on May 24, 2021, at the Shanghai Provincial Laboratory of Hyper-High-Speed Vehicles, has already achieved remarkable milestones. It's not just about speed, it's about solving the mechanics and dynamics problems of ultra-high-speed and low-vacuum pipeline maglev transportation systems. While China's hyper-high-speed train Dongsheng is currently in the test line construction stage, it's not just a project, it's a vision. With the substantial improvement in China's economic development and technological skills, the dream of a hyper-high-speed train network is within reach. That's all for today, folks. Thank you for watching. If you like this video, please show some love and support by liking, commenting, and subscribing. I'll see you next time.